Hi guys, this is Mrs. Gastler, and in this video we're going to talk about how to describe motion with words. And there's basically 4 questions that we're going to need to make sure that we answer, and so let's go ahead and start talking about those. The first question is, where is it? And to answer that question, you're going to be talking about the position of the object. That's X, okay? Sometimes it's Y and sometimes it's Z. It's a position on the number line, and that number line can go any which way you want it to. You're going to be describing that with a distance measurement, so that's going to be centimeters, meters, kilometers, inches. Any unit would be sufficient as long as you used one. It has to have a unit on it, okay? And so that's going to, there we go. It's measured relative to a reference point, and you get to pick where that is. It's called arbitrary. It doesn't really matter, but you have to have a reference point, okay? So it's going to be some meters to the left, some meters to the right, inches to the right, left, inches to the right, up or down. The direction is less important as long as you're measuring relative to a reference point. Next question we're going to answer is, how far did it go? When you're measuring how far did it go, what you're measuring is a distance or a displacement. Those are actually 2 different things that we're measuring. Sometimes they're the same, but it really depends on what the object is doing. So when we're measuring a distance, the length of the path is what we're talking about. When we're measuring a displacement, how far it is from where it started is what we're talking about. And I can draw a quick picture. If this is A, whoops, let me make that a little bit smaller. There we go, okay. If this is A and this is B, and I follow this path, to get there, the length of that line is the distance, but how far I am from where I started, that's the displacement, okay? So those are 2 different measurements of the same start and finish. So it really depends. Now, if I followed that second line that I made, then my distance and displacement are going to be the same. So it really depends on exactly what we're doing. The delta x, that displacement, is a vector because we also have to say which way we went. It has direction. Okay, we'll talk more about vectors a lot more later. But those vectors do matter. Okay, to show that it's a vector, we put a little arrow on top of the delta x like that, and in one dimension, to find that delta x, that displacement, we just take the final spot minus the initial spot, and so a negative is all, or a positive is all that we need to put on there to identify the direction. Okay. Next question that we answer in describing the motion of an object is, whoops, that's not an eraser. There we go. How fast is it moving? And that one could have 2 potential answers. And so our first one could be speed, and the second one could be velocity. And look at how close those definitions are, and also how close the symbols are. Speed is v, velocity is v with an arrow on top. Speed is the rate of change in distance over time, so how fast are we following that little line, and velocity is the rate of change in position over time. Sometimes they're kind of the same thing. When we're moving in one dimension, we don't have that squiggly line all over the place, and so speed and velocity sometimes get to be sort of the same thing, okay? When we write down an equation for these, speed is distance divided by time, and velocity is delta x divided by time. See the difference there? Very subtle differences. A lot of times we're only going to be calculating the the displacement divided by time, so it's going to be mostly focused on velocity here, okay? Next question that we're going to be answering is, how is that changing? How is the motion changing? And when we're talking about the change in motion is acceleration. So that's an A. It's also a vector, you might notice, with that little arrow on top. So the rate of change in velocity is what we're talking about with acceleration. Notice we're not talking about the rate of change in speed. It's the rate of change of velocity, and that should also say over time right there. And so that's what that looks like. That equation has a very similar format to those other 2 right there, okay? Some extra little pieces of information to kind of wrap it up. We'll talk more about those equations there and how to use those a little bit later. Some extra things here is to remember that the little triangle in front of things means we're talking about a change in, and to find it if you need to is to take the final minus the initial. And so that looks like this. For the change in position, it's the final position minus the initial position. And to find the change in velocity, it's the final velocity minus the initial velocity. And then the last thing here is that both of those, all of these, many of these, speed, velocity, and acceleration can all be either an average, which is over an extended period of time, which is what we're mostly looking at in here, because the instantaneous, which is right now, how fast is it going right now, how fast is it changing right now, requires calculus, which we're just not prepared to do in AP Physics 1. But we can think about these things instantaneous. So a good question for you to think about is, which one does your speedometer show in a car? Average or instantaneous? Okay? So hopefully you wrote some things down. If you have any questions, make sure you ask your teacher. Thank you for watching.